Hey y'all, here is your quick quiz. We're going to be starting a new topic today. What does the universe look like? But this asks, what does the Milky Way look like? Talked about that in the last videos. Okay, let's get started with our new topic though. What does the universe look like on large scales? Here is an image of what we think it looks like. We'll talk about what all that funky web is, and this comes from chapter 28. So here we go. Chapter 28.3. So section 28.3. We're going to talk about the large scale structure of the universe, how galaxies tend to get together. We have galaxy groups, we have galaxy clusters, and then the big structures we call superclusters. So we're going to define each of those things. We're moving up bigger and bigger. Started with stars, galaxies, and now we are talking about groups, clusters, and superclusters. So all galaxies in the universe are found in groups and clusters. So galaxies, oops, spelled that wrong. Sorry about that. Gotta start paying attention to what I'm doing here. Galaxies are found in groups or clusters. Notice the use of that word "or" there. This is sort of the smallest structure, and they can be either a group or a cluster. I'll define those later. But the idea is they are bound by gravity with other galaxies. They are not just out there by themselves. They are bound by gravity. Just like we talked about how Milky Way and Andromeda will eventually merge, that's because of gravity. They are bound by gravity, slowly getting closer and closer to one another. The other interesting thing about groups and clusters is that they consist of more small galaxies, things that we call dwarf galaxies, more small galaxies like dwarf ellipticals, dwarf ellipticals, and just a few giants. So more small galaxies than giants, which can be either ellipticals or spirals. So this picture over here is fairly typical. You can see a couple of spiral galaxies, some bigger ellipticals, and then lots of small ellipticals there in that picture as well. So let's start with our home galaxy. Where is the Milky Way? Well, the Milky Way is in a group. So Milky Way is in the local group. And yes, that is what it's called, the local group. Okay, we are part of the local group. And what is our local group? Well, it's the Milky Way plus Andromeda. So we have two giant spirals. And those giant spirals are the Milky Way, abbreviated, and Andromeda, which is the one that we said we were going to merge with one day. Okay, the Milky Way and Andromeda, and a bunch of dwarf galaxies. And these dwarf galaxies would be slightly bigger than the protogalaxies. Okay, so we have different levels. We have globular clusters, which are groups of stars. We have protogalaxies. Then we have these dwarf galaxies, and we think there are about 60, although that number keeps changing because we keep finding others. About 60 dwarf galaxies, some bigger than others, right? So here's a picture of the local group. How big is the local group? It's pretty big on human scales. So these two giants and lots of dwarf galaxies, they spread out over about 2 megaparsecs in space. And I want to give you these numbers so that you get a sense of scale. They are hard numbers to imagine. Remember, we defined a parsec as being a distance based on parallax, right? It's kind of hard to understand. Mega means 1,000,000, so 1,000,000 parsecs. But think big. But as we go up to clusters and superclusters, look how the numbers will get even bigger. Okay, so local group about 2 megaparsecs in diameter. So that's typical for a group. So here is our first clicker question in this lecture. In the local group, there are more what than what. Okay, and so I give you some choices with giants and dwarfs and spirals and ellipticals. One important thing to remember here is that all spirals are big. Spirals are giants. And ellipticals can be either big or small. So look back at the notes, make the best determination there. So we're going to get bigger. So the Milky Way is an example of a group. The next bigger collection, a galaxy, can either be in a group or a cluster. So remember our group, about 60 or so galaxies. Clusters contain thousands of galaxies. Okay, thousands of galaxies. And they are bigger. They're a little more concentrated, but still bigger. They are about 3 to 5 megaparsecs across. Okay, so lots and lots of galaxies, quite a bit bigger, twice as big as our local group. We are not in a cluster because we're in a group, right? Either or situation. But we have some nearby clusters. We have one called the Virgo cluster. So nearby, we have the Virgo and a larger Coma cluster. Okay, and Virgo is named for the constellation Virgo. That's where it is in the sky. Virgo contains a lot of spirals. They both, all clusters, contain dark matter. So they contain dark matter. Hopefully that makes sense. We know that each individual galaxy contains dark matter, but there's a little more to it than that. So we look at a cluster of galaxies, this beautiful picture of all these different galaxies, and then we look at galaxy clusters in X-rays. Remember, we used X-rays to find hot gas around ellipticals and said that that hot gas would have just floated away if it weren't for dark matter, the gravity of dark matter. Same thing here. We look in X-ray and we see a lot of hot gas where there's not much visible matter. So what's keeping it there? Dark matter is keeping it there. Okay, so that's what you're seeing in this picture, sort of the green and the blue in the middle of this cluster, where you don't have the brightest galaxies, but you have stuff, dark matter, keeping hot gas there. So there's a lot of dark matter in the universe. Remember, we said about 90% of galaxies, but then there's stuff in between the galaxies as well. Okay, going up, we have superclusters. Now, a supercluster is clusters and groups bunched together. So, superclusters of galaxies. Superclusters are galaxy groups, and clusters all bunched together. Okay, so a galaxy can be in either a group or a cluster, but then we all get together in a big supercluster. And yes, there is the same name, Virgo. We are in the Virgo supercluster. I'll get back to that in just a minute, but let's define superclusters here. They are hundreds of thousands of galaxies. So hundreds of thousands of galaxies. Remember, the local group was less than 100. Clusters, we said, had thousands. Now, superclusters, hundreds of thousands of galaxies, spanning a much larger size of about 30 megaparsecs. So a group was 2, a cluster was 3 to 5, and now we have a factor of 10 bigger, 30 megaparsecs. This is a picture of a supercluster that we are part of. It is the Virgo supercluster. The local group is down here. Here's the Virgo cluster that we talked about. It's part of the Virgo supercluster. Turns out, recently, we learned that we are part of an even bigger supercluster called Laniakea. And so, just to give context, let's write down our whole address. This is known as our cosmic address. But as we've been building up the pieces here, I just sort of want to give you it all together. So, our cosmic address, and this is much like you would have an address here. You would have a house number, a street, a town, a city, a state, all of this. Okay, so we live on a planet called Earth. Earth is part of the solar system. Okay, that would be our street. The solar system is out in the Milky Way galaxy. Our Milky Way is a giant barred spiral, and we are sort of out in the suburbs, okay, out about halfway between the center and the edge. This Milky Way galaxy is part of a local group of about 60 galaxies. That local group is part of a couple of superclusters, the Virgo supercluster, and then it turns out Virgo is really just a piece of the much larger Laniakea supercluster. That's a Hawaiian word. I don't remember what it means at the moment. Laniakea supercluster. And if we put all the superclusters together, we get the universe. Remember, the universe we defined as everything, right? I said we'd get back to that. Well, here we are. It's everything. And within the universe, we see this structure of superclusters all coming together.